Okay, thank you for your kind introduction. Good afternoon, everyone. So once again, I am Praveen. So I work on analysis, modeling, estimation, and control of lithium-ion batteries and its related application at Sun Mobility. So in today's session, I'll be discussing on one of the case study, that is the development and Pareto-Analysis of Degradation-Conscious optimal fast charging profiles for high energy density batteries using GT-AutoLion. So these are the contents of today's presentation. We'll begin with a short introduction of Sun Mobility and how GT is accelerating our battery development. Then we'll move on to the specific case study. So, as you may know, Sun Mobility is India's leader in battery swapping business. And why battery swapping? So, compared to other conventional fixed batteries or IC engine, battery swapping is more affordable, and also it has a better refueling time compared to the fixed batteries, and it's a lot cheaper that you don't need to buy the battery, as we provide the battery as a service. And to give a glance of Sun Mobility's operations, we have operations in more than 18 cities in India with more than 500 swapping stations, which is also called as the QAS, Quick Interchange Stations. And these batteries are interoperable, and it is integrated with different types of vehicles such as e-loader, e-auto, e-rickshaw and e-bikes, etc. And some of the technology stack of Sun Mobility. So the core is a battery, which we call it as a smart battery, along with the battery swapping cum charging station, which is the QEIS. And we have the plug and play docking system, which is integrated into the different vehicles. And all these systems are interconnected using the latest IoTs via cloud. So what is the motivation behind the fast charging and how it affects the Sun Mobility's business? So basically it impacts our assets utilization, so it improves the customer experience. And in case of asset utilization, we can say that we can increase the number of swaps per day by increasing the charging current, which will in turn improve the business. And in case of asset cost, we can lower the cost of the asset. For example, we can minimize the number of charging station in a particular region if we can use the same station using fast charging techniques. Now let's see how GT, especially the GT-AutoLion, is accelerating our development. So we are using the model-based simulation, that GT-AutoLion. So it helps in quickly understanding the battery performance in real-world scenarios, because we are operating in different cities, different life cycle, different temperatures, and also it is very cost-effective to do this analysis rather than testing, and also time-effective when compared to the experimental test. And apart from this, we can understand the cell degradation under different scenarios, how is the capacity fade or how is the power fade. And finally, we can use this model for estimation of different type of algorithm, for example, state of charge, state of health, state of energy, and we can come up with different type of charging protocols or safety controls. So among the different types of models, you can see different types of models. We use the highly accurate P2D models for these simulation studies. So as a keynote speaker and other presenters have discussed on the battery modeling, so in our case we are using a high energy density cell, which is more than 40 ampere hour, and initially we find the geometrical parameters, then we define these parameters into the model, and along with anode and cathode parameters. And in case we tackle some difficulties and in some cases if user defined parameters are not working, we have the option to improve certain parametric function which is defined by the user or we get from the literature. And finally, to model all this and to calibrate this model, so we use the basic experimental data which we already use for our characterization. For example, the OCV characteristics, then the dynamic performance data, which is nothing but the voltage characteristics at different C rates, temperatures, etc. And finally, we also need the aging data. For example, we need the calendar aging data and the cyclic aging data at different scenarios for modeling the battery.